Bright Tuty. Every student matters.
Hello students, my name is Sanjay Jain. In today's lecture, we will talk about polynomials, right? In previous classes, you have studied algebraic expressions and some topics about polynomials also. So let's first of all revisit some of the concepts and then we will continue with the polynomials of class 10th. You have studied that expressions in X are known as algebraic expressions, like x plus 2 is an algebraic expression, x cube plus 2x square plus 3x plus 1 is also an algebraic expression, and this expression is also an algebraic expression. But polynomials are special kind of algebraic expressions where the powers of x are in whole numbers, right? So the powers of the variable that we are using should be in whole number for it to be a polynomial. For example, x cube plus x is a polynomial. Yes, x plus 1 by x is not a polynomial. Why? Because x plus this 1 by x can be written as x raised to power minus 1, and minus 1 you know is not a whole number, so this is not a polynomial. So, and how do we categorize polynomials? If we can categorize polynomials on the basis of number of terms, right, and also on the basis of power of the variable, on the basis of degree of a polynomial, on the basis of degree of a polynomial. Number of terms, if let us say number of term is 1, right, for example 3x is a polynomial with single term, so this is known as monomial, right? If there are two terms, let us say 3x plus 5, there are two terms here, right? So this is known as binomial. If there are three terms, for example 3x square plus 5x plus 2, right, it is known as trinomial, because there are three terms here, and in general we can call it as a polynomial. Let us say there are more than three terms, then we can call it as polynomial. On the basis of power of the variable, on the basis of degree, what is degree? The highest power of the variable in the expression. For example, if I write 3x cubed plus 4x raised to power 4 plus 5x, what is the degree of this polynomial? It is not 3, right? What is the highest power available here? It is 4, right? So the degree here is 4, okay? And on the basis of degree, we can categorize polynomials. For example, if let us say the highest power is 1, okay, we call it as linear polynomial. If the highest power is 2, we call it as quadratic polynomial. The degree 3 is known as cubic polynomial, right? And degree 4 is known as biquadratic, and so on, right? So we can categorize broadly in two ways: on the basis of number of terms, where is monomial, binomial, trinomial, and so on, and on the basis of degree, we can call it linear, quadratic, cubic, biquadratic, and so on. There is another polynomial like this. If I write only a constant term, this is known as constant polynomial. This is known as constant polynomial. What is the degree here? I can write this as 3 into x raised to power 0, right? Anything raised to 0th power is 1. So 3 can be written as 3 into x raised to power 0. So the degree here is 0. Degree of a constant polynomial is 0. And if I give you a polynomial, let us say I give you only 0. What kind of polynomial is this? This is known as zero polynomial. Zero polynomial. And students, you need to take care that the degree of 0 polynomial is not defined, right? Why? Because if I write 0 like this, 0 into x raised to power 1, I can also write it as 0 into x raised to power 2 or 0 into x raised to any power. Let's say I write x raised to power 5, right? So we cannot define what is the degree here because it will take all the powers of x, right? So degree of, you can make it a point, degree of 0 polynomial is not defined, right? So moving on, let's come to class 10th topic, which says, let us say first of all we take value of a polynomial, value of a polynomial. Right? We can write polynomials like this: f of x is equal to, let us take x plus 3. Okay, what is f of x? This is function of x. It is the values that you obtain when you put various values of x. For example, if I put x equal to 1, I will get f of 1, which is equal to 1 plus 3, which is equal to 4. Right? In this expression, x is known as independent variable. And f of x is also a variable. It depends on the value of x, right? So it is dependent variable. Right? Graphically, if you see, you make these rectangular coordinates. This is known as x-axis. This is known as y-axis, right? This is a line 1, 2, 3, 4. This is 0, minus 1, minus 2, minus 3, right? This is a line where all the real values can be written, right? If I take, let's say, any value of x, I take 2 here, right? If I put 2 in this expression, it will give me f of 2 equal to 2 plus 3 equals 5, right? When I put 2 in this expression, it will give me 5. So the point will be here, right? This is the meaning of value of a polynomial. I put certain value of x here and I get certain value of y here. Y is also known as f of x. Okay, you can call it y also. Y equal to f of x equal to x plus 3. So this is how we think about values of a polynomial. For example, if I take any other polynomial, let's take a quadratic polynomial. In quadratic polynomials, the graph will be of the shape a parabola. This shape graph is known as parabola. This is known as parabola. Right? This is one of the graphs of quadratic polynomials. We will discuss all the graphs in great details. So if I say, let's say this is point 1, right? What will be f of 1? I will just see the value opposite to it and go towards y-axis. So this is my f of 1. This value is f of 1. So now if I ask you whether f of 1 is positive or negative, you will say that it is positive because it is in this direction, right? This is the positive direction of y-axis. So f of 1 from this graph is clearly positive. If let us say this is 2, right? Now if I ask you what is f of 2, is it greater than 0, is it lesser than 0 or equal to 0? Clearly if you go towards x-axis from this, y-axis from this point, you will see that it gives you 0. So f of 2 is equal to 0. There is another point where it will give me 0 value. Let us say this is point number, this is x equal to 5, okay? At x equal to 5, it will again give me f of 5 equal to 0, right? So the value of this polynomial at this point is 0 at this point it is again 0. And if I ask you, let us say at this place I take x equal to 3, right. So let us say this is 3.5 to be precise. Okay. So if I ask you what is f of 3.5, is it positive, is it negative, or it is 0? What I'll do is I'll go towards the graph, and on the graph I'll look towards the y-axis. So this is the value f of 3.5, right. So f of 3 point is positive or negative? Obviously it is less than 0, right, because it's in the downward direction, right. So this is how we visualize the value of a polynomial. And the values where the values of x, where f of x is equal to 0 are known as zeros of the polynomial. Okay. So if I go back to the graph and I ask you what are the zeros of this polynomial, what were the values of x where the f of x was 0? It was at 2 and 5, right. So zeros of this polynomial are 2 and 5, right. So this is about zeros of a polynomial. And if you will appreciate that wherever the graph cuts, right, let's say this is a linear graph, wherever the graph cuts the x-axis, at those points the y will be 0, right. Wherever the graph cuts the x-axis, what value you will obtain on the y-axis? It will always be equal to 0, right. So the cuts on x-axis will also give you number of zeros. For example, if I take this, right, these are the two places where, let us say this point is A, this point is B. So if I ask you what is f of A, you will say f of A is 0. If what is f of B? F of B is also 0. So A and B are zeros of this polynomial, right. So when I said that degree of a zero polynomial is not defined, we can also think about it graphically. What is a zero polynomial? It is equal to 0. So what is equal to 0? F of x is equal to 0, right. And what is f of x? It is equal to y, right. It is dependent variable. So f of x is here and x is here. So when I say f of x is 0, so where is f of x 0? What is the line which is y equal to 0? On this line, at every point you will have y equal to 0. So when I say f of x equal to 0, I am just referring to x-axis itself. It is x-axis itself, right. And wherever the graph cuts the x-axis is known as 0. So f of x equal to 0 is the complete x-axis, hence the number of zeros is not defined, because it is complete. Every point on x-axis is 0 of this polynomial, right. And how many points are there? It is undefined, right. So this was about zero polynomial. Okay. So this was broadly about value of polynomial, zeros of polynomial and all this. So now let's move on to general form of a polynomial, right. And to be very precise, we will have to write general form of a nth degree polynomial, right. So if I write a naught x raised to power n plus a1 x raised to power n minus 1 plus a2 plus a3 and so on. So you notice that powers of x are decreasing with every term, right? So the last term will be an, it will not have any power of x, and the second last term a of n minus 1 into x, right? If I write a polynomial like this, let us say it is equal to f of x. You can take it as p of x, q of x, that doesn't matter, right? You can choose any variables, x, y, q, p, r, any variable, right? So this is the general form of a polynomial. It is an nth degree polynomial if you write that a naught cannot be equal to 0, right? So now it is an nth degree polynomial. This a naught is known as leading coefficient. It is known as leading coefficient. A naught, a1, a2, a3, an are, these are real numbers, okay? We are dealing with real coefficients here. So these are known as coefficients, okay? And every expression separated by a plus sign here is known as a term of a polynomial. These are called term of a polynomial. Okay, if I ask you, whatever this is written on this board, if I say that all of these coefficients are non-zeros, how many terms are written here? You can count these terms. This goes up to 0 to n. So there are n plus 1 terms written here, right? But this is in the case when no coefficient out of these is 0. If any of the coefficient becomes 0, then the number of terms will become lesser, right? But this coefficient cannot be 0 for it to be a nth degree polynomial, right? I have written this polynomial in a standard form. What is a standard form? Where the powers of x are written in descending order or ascending order. So I have written it in descending order. Powers of x in descending order, right? Or you could have also written in ascending order. All right. So this is the standard form, and a naught, a1, a2, an up to an are known as the coefficients. These are known as the terms of a polynomial. And what is the highest power here? Highest power is n, so this is an nth degree polynomial, right? For it to be a 0 degree polynomial, what will happen is, if I put a naught equal to a1 equal to a2 equal to a3 equal to up to an, if all the coefficients are 0, then it will become, if all the coefficients become 0, the entire right hand side will become 0, right? So f of x equal to 0. So this is our 0 polynomial. And if I write x equal to 1 here, what is f of 1? It will be equal to, I place x equal to 1 in each and every term, right? So what will it become? A naught plus a1 plus a2 plus up to, right? This is sum of coefficients. This is sum of coefficients, right? So if I place x equal to 1, it will give me sum of coefficients, right? What will happen if I place x equal to 0? What will be f of 0? It will be nothing but these all terms will become 0, right? Except this term, right? I will be left with only the constant term. So it will become constant term only, right? So where do I find it on the graph? This is x-axis, this is my y-axis, right? So if I have to put x equal to 0, this is the point, right? This is my origin. If I put x equal to 0 and let us say I get y equal to for example, let us say this is the polynomial. If I put x equal to 0, I will get y equal to this, right? So this is my f of 0. For example, let us say if I want to take second degree polynomial only, second degree what is the name of second degree polynomial? It is known as quadratic polynomial, right? So what will be the standard form of a quadratic polynomial? Ax square plus bx plus c, where a, b, c are real numbers. A, b, c belong to real numbers. This symbol means belongs to, right? And a is not equal to 0. What will happen if a is equal to 0? It will not remain a quadratic polynomial, right? This term will vanish, then it will be left with only linear terms, right? So to write second degree polynomial in standard form, I have written expression in descending order of powers of x, 2, 1, here x is equal to 0. So what is f of 1 here? It is a plus b plus c. What is f of 0? It is equal to c only, right? So if I give you something like this, right? So and I ask you what is the value of c here, you will just say that f of 0. So this much is c, this much is c, right? So if I ask you what is the sign of c, you will say it is positive in this graph, right? If I give you a graph like this, let us say this is the graph, and I ask you what is the sign of c here, you will say it is negative, because f of 0 is c and c is below the x-axis. So f of 0 is equal to c, okay? And what are these two places? These two places are zeros of this quadratic, right? Let us discuss other graphs which are possible of a quadratic polynomial. Graphs of a quadratic polynomial. First point that you need to understand, that the graph of a quadratic polynomial will always be a parabola, right? Now this parabola can open upwards or downwards, right? Parabola will open upwards if a is positive, and it will open downwards if a is negative. For example, in this case a is positive, where I am considering the quadratic polynomial as ax square plus bx plus c, okay? If a is positive, it will open upwards, and if a is negative, it will open downwards. So it is opening upwards, it is opening downwards, right? Secondly, if the discriminant is greater than 0, it will have two real roots, right? If the discriminant is greater than 0, it will cut at two places on the x-axis. Let's say this place is alpha, this place is beta, right? It will have two distinct roots, or it will cut at two distinct places if discriminant is greater than 0. If discriminant is equal to 0, it will only touch the x-axis, right? It will touch the x-axis at one place, because both the roots are equal in this case, okay? And if discriminant is negative, it will not touch the x-axis. It will either open upwards or open downwards as per the sign of a, right? So what I can say here is, if you are not comfortable with discriminant, you will become comfortable in quadratic equations. Otherwise, you can think about these graphs like this, this quadratic polynomial graph cuts at two places, so it means it has got two distinct zeros or two distinct roots, right? This has got two equal zeros and this doesn't have any real zero, right? Okay.